Hey guys, yesterday we talked about, or not yesterday, previous lesson, we talked about two lines being cut by a transversal and the angle pairs that made. Today we're going to be talking about some special properties that those angle pairs have if the two lines are parallel. Okay, that's a big if. So this only applies in the special case that the two lines are parallel. So we make sure we want to clarify that here. So if two parallel lines are cut by a transversal, then dot, dot, dot. So we're going to talk about a couple properties, one for each angle pair that we learned yesterday. So we learned four, and these all have names, all right? So you kind of need to know these names, but the names are basically the same as the names of the angle pairs. So the first one is the corresponding angle postulate, okay? So if two parallel lines are cut by a transversal, then corresponding angles are congruent, okay? So remember what congruent means for angles. Congruent means they have the same angle measure, okay? So why don't we need to prove this, all right? So for all the other ones, I'm actually going to prove them for you. They're pretty short, okay? Well, why don't we need to prove the corresponding angle postulate? Well, if you remember, all right, the difference between postulates and theorems is we don't need to prove postulates. Postulates are what we assume to be true, okay? We don't need to prove postulates. So we're going to use the corresponding angles postulate essentially to prove all the other ones, okay? So the next one, all right, is the alternate interior angles theorem, okay? So see how we had one for corresponding angles, now we're going to have one for alternate interior angles. So the alternate interior angles theorem says alternate interior angles are congruent. So just like corresponding, alternate interior angles are also congruent, okay? And we're actually going to prove this here, okay? So looking up at this picture, all right, this picture up here, we're actually going to prove that 3 and 6 are congruent, and the same proof could be used for 4 and 5, okay? So the way that we're going to do this, so we're given that L and M are parallel, all right? So a lot of times you're going to be given that to start, because without knowing that they're parallel, none of these apply. So we got to know that they're parallel. So because they're parallel, all right, now we know that corresponding angles are congruent. So if I'm trying to prove that these two are congruent, okay, I also know, because of the corresponding angles postulate, that 2 and 6 are congruent. So maybe you see where I'm about to go here, but we can say angle 2 is congruent to angle 6, and that would be by the corresponding angle postulate, all right, the one we just used above. I also know that 2 and 3 are congruent, and that is from vertical angle theorem, so that. And so now you can kind of see what we've got set up here. We've got 2 is congruent to 6, we've got 2 is congruent to 3, so now we can say 3 is congruent to 6, and that would be by our good old friend, the transitive property. All right, so because we knew the corresponding angle postulate, we were able to use that to prove that alternate interior angles were also congruent. All right, so we got a nice little proof there. The next one that we're going to use is the same side interior angles theorem. All right, so we talked about this yesterday. So this one actually breaks the pattern that we've had so far. So same side interior angles are not congruent. All right, they are supplementary. So if you remember what supplementary means, it means they add up to 180. Okay, so we're going to try and prove that here. Okay, we're going to try and prove that angle 3 and angle 5 add up to 180. So again, we're given that lines L and M are parallel. And so the cool thing is that now that we know the alternate interior angles theorem, okay, now we can use that to help prove this, okay? So I'm actually going to start with the alternate interior angles theorem, all right? So I know that angle 3 is congruent to angle 6 because they're alternate interior angles. So again, these are things we want to know. Now I also know that angle 5 and angle 6 are supplementary. All right, how do I know they're supplementary? Because they're a linear pair. All right, if we look at this picture, remember, anytime two angles make a straight line, that's a linear pair. So I know 5 and 6 are supplementary. Now, because I proved this with the alternate interior angles theorem, all right, I can now substitute, all right, angle 3n for angle 6 in this equation. And that would be substitution. And now we're actually done, because that's all we wanted to show was that angle 3 and angle 5 added up to 180. So I just proved that same side interior angles are supplementary, and the same proof would work for 4 and 6 as well. So that's another thing that you need to remember, okay? The last thing is the alternate exterior angles theorem. And what do we know about alternate exterior angles? So here we're actually going to go back to the pattern, all right? Alternate exterior angles are congruent. So 3 of the 4 things are that they're congruent. The only thing you need to remember is that same side interior angles are supplementary. And you should be able to tell that they're not congruent because this is small and this is big. For all the other ones, like 1 and 8 alternate exterior angles, it's big and big. Okay, so you kind of can figure out just by looking at it what they are. So I want to prove that angle 1 is congruent to angle 8. Okay, and that's going to be another easy one to prove. So again, all we're given is that lines L and M are parallel. But because we know they're parallel, that lets us use all of our other properties. Now, the only one we actually need here is corresponding angles, cap. All right, so I'm going to say that 1 is congruent to 5, because remember, I'm trying to get 1 congruent to 8. So I'm going to say angle 1 is congruent to angle 5, and that's by the corresponding angle postulate. Okay, now, remember, we're trying to get from 1 to 8, so I've got from 1 to 5. Now I can go 5 to 8 from vertical angles. So that's the vertical angles theorem. And then I can finish it off. So I've gone 1 to 5, I've gone 5 to 8. So now I can go 1 straight to 8, again, with our good old friend that I told you we're going to use all the time, the transitive property. Okay. So these are the notes for today. Do you need to remember the proofs? Kind of. But hopefully you can kind of figure them out, but you definitely need to know what the theorems say, all right? Alternate exterior angles are congruent. Same side interior angles are supplementary. alternate interior angles are congruent, and corresponding angles are congruent, okay? So that's the notes. Hopefully you can use that to help you complete the practice. If you have any questions, bring them to class, and have a great day.